Now, guys, you have to pay very careful attention to this marking now because it's the last practice that we're going to do on this stuff before your test on them. Okay, we're not going to go over geometry equations again after today. So you have to please pay attention. All right, so for question 4, which was on page 132, I hope the page numbers were also contributed from on page. All right, so what you have to do for 4.1, this is actually like last term's work, right? Where you just have to find one angle in a triangle and even with the other two. And then you say 180 minus the two angles that they gave you, which was 38 and 53. The reason is angles on a triangle and your answer is 89 degrees. Okay, so you can use our mark for this, guys. One mark for 89 and one mark for 30. So if you get a question like that in a test on Monday, it will be worth it. Okay, the next one was a bit more complicated. We did one like this in class on Friday, where they have given you the three angles, but two of them are in terms of B. Do you guys remember the word in terms of? We spoke about that last week. I'll just show you quickly the example that we did last week was this one, where you have to calculate the value of x. Right? This one is actually a bit more complicated than the one that we're marking now. We first have to find this angle at C because it was an isosceles triangle, right? And then we have to say all three of these angles added together is equal to 180 degrees. Right? All three of these angles added together is equal to 180 degrees, and the reason is then angles come in five. Okay, and then we solve for x from this. So that is exactly what we need to do in the next question, question 4.2. We have B and we have 2B and we have 27. And we all know that the three angles in a triangle add up to 180. All right, so that's what you do. Guys, you get a mark just for writing that line. Okay, not even calculating B, just for writing out that you know that the three angles added together is 180. And then for angles on a triangle from there. Then for the next few steps, yeah. It will be 180 over 3. It won't be b over 3. It will be 180 minus 27 over 3. Okay, so rather write it off like this. I remember last term, when, yeah, I think rather don't try and skip steps. Don't try and do all the steps like at once. Okay, rather write it off properly like this. Okay, now in the next step, you could have added the B and the 2B together straight away. Okay, I just wrote them again, but you could have just said B plus 2B is 3B, so it's fine if you wrote 3B there already. What's the opposite of adding 27? Subtracting 27, good. And that's 153. And now what's the opposite of multiplying by 3? Dividing by 3. So if you have 153 divided by 3, the answer is 51. Now you do have to be able to do a division question like this in your next, okay, without a calculator. So you can think 153 divided by 3. We all know that 150 divided by 3 is 50, right? And then 3 divided by 3 is 1. Okay, so you can also do it like that. If you can't, you know, to think of the whole value 153 divided by 3. But you can be asked to do something like this in Monday's test. Remember, it's a no calculator test. Okay, so you will get 1 mark for that step, basically for doing the minus 27. And then you will get a mark for the answer there. So this is a 4-mark question. Okay, 4.3 is also like a typical test question where they've given you a diagram. You have to find the values of multiple variables. So they will tell you, if it's like this in a test program, they'll tell you that you have to do them in alphabetical order. In this case, suppose you could have found D by doing exterior angle of a triangle, but I think it was easiest to just find C at first, right? Because do we see that these two angles are on a straight line? 100 degrees and C. So C is going to be 180 minus 100. right? Because that's 180 minus 100, that's going to give you C, and the reason is angles on a straight line. So for that step, for calculating speed, we take 2 marks. Okay, now like I said, for D, you could have used exterior angle of the triangle. Did anyone do that to calculate D? Okay, if you did, you were supposed to get the same answer, right? That's fine. It would have been a bit quicker, but what I did was I just said, okay, now that I know that C is 80, do we see that we can use angle sum and triangle again? You try it? No, that's not. All right, so if we're looking at these 3 angles, do you guys see what I wrote? 2D, which is that angle, plus 3D plus 20, which is that one, plus C, which we now know is 80, right? I showed you that with an arrow, that 80 degrees is from our answer, right? Is equal to 180 degrees, and the reason is angle sum and triangle there. And then from there, you're just going to have to solve that equation, right? So what I did here, from this line to the next line, I didn't do any opposite operations yet. I just had 4 terms, which is a bit much. So I just added them together first. Okay, so 2D plus 3D is 5D. And then I did 20 plus 80, which is 100. So that's all I did from that line to the next. Okay, and then I said, what's the opposite of adding 100? Subtracting. So I did that next, which is 80. And then what's the opposite of multiplying by 5? Dividing by 5. So that gives me an answer of 60. Okay, for this, you will again get a mark for your line and for angle sum and triangle, and then 1 mark for, now if you did exterior angle of the triangle, your working would have been slightly different, but you'll get a mark for moving the number across and then for dividing. So that is also 4. So this whole question, by finding C and D, is 6 marks. Okay, which is 12% of the text. Remember, all your math groups are out of 50. All right, so a 6 mark question would be 12%. Are there any questions so far? No. All right, 4.4. There we go. 4.4 is actually very similar to the one that we did in class, but it just had less variables. Do we see that this again is an isosceles triangle? Right, because those 2 sides are equal. So guys, if this angle E is opposite and equal side, right? Then the other angle that is opposite the equal side is also going to be equal to E. You have to write that down, right? If you don't write that line down, you're going to lose 1, possibly 2 marks. Okay, even if you redrew the triangle and you put it in the triangle, so you have to actually write it down. So please, if you didn't add that in now, right at the top. That's the first thing that you need to write down. Okay, so you need to say that angle C is equal to E because of angles opposite equal sides. Guys, remember, it has to be exactly like this. You can't like swap the words around. So you can't say like angles equal opposite sides or something. It has to be angles opposite equal sides. Because that's what's happening, right? Look at my arrows. I'm drawing an arrow to the angle that is opposite one of the sides that are equal. And then the other angle is also opposite one of the sides that are equal. So that region has to be angles opposite equal sides. And I know it's a bit of a pain, all right, to remember that, but please have to write it for your. Then from there, I have to do this a bunch of times in this question. That angle plus 25 is 180. Hang on. Angle sum and triangle. Then I just added the e's together. That's 2e. Now, guys, it's fine if this was your first line as well. All right. If you just saw, oh, e and e is 2e, you could have written that as your first. I mean, instead of that line there. So that would have been a mark, angle sum and triangle. Then you would have to subtract 25, right? So that would be the next mark. And then you would have to divide by 2, and that will be the next mark. Okay? Yeah, but do you have that line? Yeah, so you must write the first line and then you can do the going on from it. Please. I got the right answer, but like I think we're working out correct. I just don't have to begin it. Please. That you do have to have a line that shows the person that's marking, right? That you know that the three angles in a triangle add up to 180. Okay, so like I said, when you're solving equations here, like remember I told you guys you don't have to write this line, right? The 180 minus 25. You don't have to write that, for example. But guys, you do have to have either this line or that one to show me that you know that those three angles together equal to 1. Okay, yeah. That's what I'm going to do. Okay, already fun. The next one was also like that one, basically, just a little bit more complicated. So again, this is an isosceles triangle, right? Those two lines or those two sides are equal. So the angles opposite the equal side will have to be equal as well. So this one is x plus 20, that one is also x plus 20, right? Third line, you didn't write that down, add it now. Sorry. Beautiful. I'm gonna work right now. Okay, so again, one mark for writing angle D, one mark for the region. Guys, you can ask me if you have like a variation of this line. But again, you have to show me that you know that the three angles added together will equal 180. Okay, but you might have written x plus 20 plus x plus 20 equals, oh, sorry, 180 minus 40. That's just okay if you did it like that. And then angle, sum, and triangle. I hope you are remembering to write that reason. You will get a mark for getting to this line, guys. 2x is equal to 100 degrees. And then a mark for x equals 6. Now, guys, obviously in this question, you have to do the same thing quite a few times, right? So like 4.4 and 4.5, they were basically the same thing that you had to do. In a test, you won't get that. All right, so you won't get like 2 6-mark questions where you have to follow the exact same method, same reasons in both questions. All right, but you can get one of them. And then something different. Are there any questions? I'm gonna move to the next page. If you just missed anything there, you can ask me. You can come look at it later. Now, 4.6, guys, this is like a typical test question. Okay, where it's a diagram that looks a little bit different from what we've seen before. We haven't really seen a diagram that looks exactly like this. And you have to find 3 variables. Okay? So you have to find G, and you have to find H, and you have to find J. And all 3 of them, if I'm not mistaken, actually G and H you have to do in the same way, but then to find J you have to do something different. All right, so for G, do we notice this angles on a straight line thing happening? Right? So you're going to say G plus 5 is equal to 180 minus 120. Right? Angles on a straight line. Guys, you could have written it slightly differently. I'll just add it at the top. You also could have said G plus 5 plus 120 is equal to 180. Right? If you wanted to write it like that, you could have first just said the 2 angles that are on the straight line must add up to 180. Okay, then your next line would be, okay, now I'm minusing 120. Right, so it's fine if you write that first with your reason next to it. Either way, whether you have that line or that line, you will get a mark for it and a mark for your reason. So again, just for showing me that you know that the two angles on a straight line add up to 180. 180 minus 120 is 60. Guys, it's even okay if you wrote this as your first line. Right? If you did the 180 minus 120 in your case, that's okay. But then your angles on a straight line would be next to that. Whatever your first line is, you need to have angles on a straight line next to it. Now, what's the opposite of adding 5? Subtracting 5. So next you would have to subtract 5. So G is 55. Any questions on G? H is a bit easier. H is just angles on a straight line, right? If you look at that, let me show you again. Here we have H and 105, those two angles on a straight line. Alright, so H is going to be 180 minus 105. We didn't have to solve an equation for H. We could just do that calculation, 180 minus 105, and we got the answer of 75. Reason, angle on a straight line. This would just be worth 2 marks. Okay, now for J, what I did was, we now know that H is 75, right? So we can use that. So I did angle sum and triangle. Okay, so I say 2J plus 65 plus 75 is equal to 180. Angle sum and triangle. You also could have done exterior angle of a triangle if you wanted to. You'll get to the same answer again. So 1, 2 marks. Then if we're looking at this, what's the opposite of adding 65? Subtracting. And the opposite of adding 75? Subtracting 75. So if you work all of that out, guys, you actually get to 40 degrees. Alright, so that would be the next mark. And now the opposite of multiplying by 2 is dividing by 2, so the answer is. So what's that for that whole question? 1, 2, 3, 4, 5, 6, 7, 8, 9 more. Any questions on that one, guys? Okay, now the next question was actually a bit silly. It was on page 1.39, right? Number 3. Again, you didn't have to draw all the pictures. I just drew them so that we can look at them while we are marking. Now guys, we haven't spoken about angles around a point in ages. I'm not sure if you actually remember how that works. Can we use angles on a straight line to calculate y? Is y actually on a straight line with another angle? No, hey, if we look at y and 33, that's not a straight line, right? So I can't use angles on a straight line there. And if we're looking at y and 148, that's also not a straight line. So you can't use angles on a straight line if I don't actually have two angles on a straight line, right? But what we do have, guys, sorry, let me zoom out a bit so you can see that whole answer. What we do actually have here is we have 4 angles around a point. And do you guys remember that angles around a point add up to 360? Okay, you have to know that as well. Yes. Revolution, yes, that's the other option. So your reason here can also be revolution. I'll add that now. So guys, if you have these 3 angles, you're finding the fourth one. You're going to say y is equal to 360 minus those 3. Okay, and your answer was then 87 in this case. So the other reason that you could have said here is revolution. You'll also get a mark for doing that. That's also on the list of reasons in the past document. So you will get 1 mark for the answer, 1 mark for the reason. It's just a minusing, so they'll just give you 1 mark for that. Yeah, we're fine with that one. Now for the next question, you'll see that I have three options. Because in this case, I think it looks like you have to use angles around the point, right? Because they've given us all the angles around the point. But look at that. That's actually angles on a straight line, right? So we could have used those two angles on a straight line. And even there, x and 150, do we see that those two angles lie on a straight line? That's actually a very easy question, right? What is x going to be there? 180 minus 150 because of angles on a straight line. If I look at this, those two, right? X and 150, those two angles are on a straight line. So if you notice that, right, if you saw that you can actually just do a quick calculation actually to find x, that would have been quite nice. You could have saved yourself some time. So you would have just said x is 180, because those are the angles on that straight line, minus 150. Okay, to get you to 50. Or if you wanted to use the angles above the straight line there, you could have said x plus x, what's x plus x? 2x must be equal to 180 minus 120. All right, that also would have worked because what is 180 minus 120? 60, right? And then what do I get when I say 60 divided by 2? Also 50. All right, so you would have gotten the same answer. I didn't do the whole calculation, but you would have gotten the same answer of x equals 50 if you did it like that. All right, so 2x would be 180 minus 120, and then you would have to divide by 2 after that. Or if we are looking at, sorry, we just erase this highlight a bit here. If we are looking at this section, right? What is x plus x plus x? 3x, right? So that whole blue section is 3x. And then 120, and then 150. What should all of this add up to? 360. So if you want to calculate what 3x is equal to, you could have said 360 minus 120 minus 150. Okay. And then your reason would be angles around the point, or again, you can say revolution if you prefer. You would then have to calculate that, right? That will give you 90 degrees if you work that out. And then what would you have to do? What's the opposite of multiplying by 3? Dividing by 3. What's 90 divided by 3? 30, okay? So you would get the same answer as x equals 50. So it's up to you which option you wanted to use there. The first one is just the fastest way. Okay, but you would get to the same answer regardless of which one you use. And then after that, I think every single question was angle on a straight line, which is a bit irritating, but yeah. So for 3.3, you can see there A and 115. So you're going to say A is 180 minus 115, angle on a straight line, and then you just work that out at 65. All right, the next one, we have C and 70 and 50, but again, all three of these angles are on a straight line. So you're going to say C is equal to 180 minus 70 minus 50, and the answer is again, angles on a straight line. Now, guys, in your test on Monday, if you are using angles on a straight line twice, right, say in question 1 you're using it, in question 2 you're using it again, you have to write it every single time you use it. Okay, so don't think, oh, I wrote it once, I don't have to write it again. Every time you use it, you have to write the reason. Okay, that goes for all of the reasons. The next one was a little bit more complicated because they gave us two angles in terms of B, all right? So both of these angles were expressed or were written by using the variable B, but we know that angles on a straight line add up to 180. So B plus 3B must equal 180. Angles on a straight line. Okay, B plus 3B is 4B, so we need to just work that out. And now the opposite of multiplying by 4 is just dividing by 4. Okay, so B was equal to 45. I think the rest of that number 3, I'll just post it on Classroom because it's basically the same thing. Every single question was angles on a straight line. And I actually want to get to 9.4 and 9.5.1. I don't know if you guys got as far as doing these questions. I sat 2 minutes already last night doing so I'm nothing. For those of you that made the effort. All right, so 9.4. Here you have to solve for x and y. So you have to calculate the value of x and the value of y. Now these two questions, right? 9.4, I can't actually remember how 9.5.1 looks like, but basically 9.4 is a type of question that you can expect on Monday. All right, because it includes a triangle, you have actually an isosceles triangle here, right? I hope you guys noticed that. And then you have parallel lines. Okay, so they can take a wide variety of things within this one question. Now, if you're solving for x first, let's just look at the diagram for those of you that didn't get to this question. We have triangle ABC. You can see that it's an isosceles triangle, right? So if you want to, you can do your little arrows. So that angle is going to have to be equal to that angle. Okay, we might need to use that later on. So I'll write it down if you have to. And then let's look at this shape, guys. Do you notice that I have a Z shape here? Remember I told you before, they're not going to give you parallel lines if you don't have to use them. So as soon as you see those arrows, guys, I want you to be on the lookout for, is there a Z shape? You can even highlight it if you want, all right? It's your text paper. You can do on it whatever you want. It's fine. You can draw on it. You can fill stuff in on it. So you're looking for a Z shape or an X shape or a C or a U shape. All right. As soon as you see parallel lines, you have to look for one of those 3 shapes. So here we have a Z shape, right? That angle is 2x minus 10. That angle is 40. If these 2 angles lie between parallel lines, what are they? Alternate angles, and they are going to be equal to each other, right? So that's what we needed to use to calculate x, guys. You have to say that angle there, 2x minus 10, is equal to that angle there, 40 degrees. And it's a Z shape, so the reason for that is alternate angles. You just write an alt angle. And remember, guys, you have to write which lines are parallel. So it was AB and CD. What do you do if they didn't label those lines? Parallel lines, yes, thank you. Okay, so you always, guys, you will never be allowed to just write alt angles. Okay, if you do that, you don't get them off. You have to say alt angles and then list them, the lines that are parallel, or alt angles and just write parallel lines if they didn't put letters on the end of the line. Okay, so let me show you in terms of marks. 1 mark, 2. That would be your second mark. Now the opposite of subtracting 10 is adding 10. So 40 plus 10 is 50. That was your third mark. And now when you are timesing by 2 here, what's the opposite of multiplying by 2? Dividing by 2. So 25. Okay, so 4 marks just for getting to x. Now we need to calculate y, which was a little bit longer because of this whole isosceles triangle business. So if we're looking at this, now guys, this angle at C, right? The angle, we just calculated x now. Is this an exterior angle of my triangle, ABC? I mean, it is on the outside of the triangle, but does it classify as an exterior angle? Can anyone remember what an exterior angle is? It has to be a specific type of angle. Okay, yeah, you almost there. Yes, I think you have the right idea. Yeah. Yes. So the angle has to be on the outside of the triangle, but it has to actually be like this side BC has to be lengthened, and then that's the exterior angle there. Okay. So if they did this, that would be the exterior angle of the triangle. Okay. Just a reminder of that. Don't draw that in. So we unfortunately can't use exterior angle of a triangle here. What we can do, and what we had to do was angle sum and triangle. Now guys, again, you have to notice that this is an isosceles triangle, so that you know that if that angle is 4y plus 50, This one is also 4y plus 6. All right. Can I now just say angle C? There's two angles there, right? You have to be specific. I actually wrote the wrong thing here. You see, I wrote ACB, but that angle is ACB, guys. Oops. What is my angle here? What's the name of this one? ACB. All right. So make sure that you are just writing the correct angle there. ACB. Okay, ACB is 4y plus 50. The reason for that is angles opposite equal sides. And then you can do that same calculation that we practiced so many times in the first section of this work. The one angle 4y plus 50 plus the other angle 4y plus 50 plus 40, which is that top angle, is equal 180. So again, 1, 2, 3, 4, 5. And this was actually a bit more complicated, guys, because we also see from this line to that one, I actually did some simplification already. I simplified this. I said 4y plus 4y is 8y. And then what's 50 plus 50? 100 plus 40 is 140. Okay, so you see where that 140 came from. I just simplified that line. So now I ask myself, what's the opposite of adding 140? Subtracting 140. So that gives you 40. Okay, so that's that line there. And then what's the opposite of multiplying by 8? Divided by 8. So the answer was 5. 5 degrees. Guys, remember if you calculate an angle, you have to put that degree somewhere there, right? I don't know, maybe you forget in that. Just please check that you are right in 5 degrees, not just 5. Okay. So that is a 10-mark question, guys. 10. 4 marks for getting to X, 1, 2, 3, 4, and 6 marks for getting to Y. 20% of your group on one question. And guys, how many marks of those were for reasons? Only 3 of them, hey? But these reasons are very important. Okay, can we move on to 9.5.1? Oh yes, this one. Okay, this one wasn't too complicated. You didn't actually have to solve any equations for this one. This is kind of like a question that I could have given to you before we did equations, right? Just a geometry question. Okay, so A, B, C, D. Guys, again, if they're giving you letters in a specific order, you have to probably find them in that order, all right? If we are looking at how we can find A, again, guys, what did I say about parallel lines? They're not going to give them to you if you don't have to use them. So do we notice that F-shaped thing? Yes. Thank you. All right, so corresponding angles. And they lie on or between or underneath whatever you want to use there. Parallel lines, so they are going to be equal. So A is 90 degrees. Yes, corresponding angles. Now guys, you have to be very careful here because they actually gave us 2 pairs of parallel lines. You have to write down the correct pair. So which 2 lines gave or formed that F shape? It was PR, you also put it to PS, that's fine. Parallel to MN. Those lines are also parallel, guys, but those 2 have nothing to do with the F shape. Yes? Alright, are we finding that one, guys? Okay, let me just quickly erase that X so that I can show you the next one. For the next one, we had to find B. Now, B was maybe a little bit more difficult to see because you might have been stuck on that X, right, after using the F shape to find A. But I just want to show you guys this. Right, do we see that we have a Z shape there? Okay. So angle B is going to be equal to 45 degrees because of alternate angles. Right, because the arrow is over here, but this is one line, right? So this path, PS, is parallel to MS, even though the arrows are down there. Okay, it's one straight line. Doesn't matter where they put the arrows. Yeah. Okay, so B is 45 degrees because of that Z shape, alternate angles. Again, the correct pair of parallel lines, these are the ones that are forming the Z. PR parallel to MS. Alright, we'll see guys, I just said angles on a straight line because now I know that A is 90 and B is 45, right? That's fine? So you could have done angles on a straight line. Oh, I actually did it. Sorry, you could have done angles on a straight line, but what I did was angles on a triangle. Right? 180 minus 90 minus 45. Exact same calculation, right? We'll get 45 degrees. Doesn't matter which one you use. So you could have written angles on a straight line here as well. And then for D, I used the C shape. Just quickly erase this again. We have a C shape here, which we actually don't use that so often, right? Just make sure that you don't forget about that C shape. It was 45 degrees, right? So that's a 45-degree angle. So we notice that C shape there. These two lines are parallel. So with the C shape, co-interior angles, they add up to 180. So they're not equal, like alternate and corresponding. They add up to 180. So if you want to find B, you're going to have to say 180 minus that one, B, which was 45. Yes, right? Okay. Yeah. All right, guys, now for when you're writing co-interior angles here, you need to again just make sure that you are writing the sides or the lines that are forming the C. So you can't now write PR and NX. Those two lines actually are not forming the C shape. You have to write SM or MX and NR or R. Those two lines. Okay. So be aware. Oh, I wrote MP. NR. Not MP. Oh, I can just add a little tail to it. There you go. Okay, MS and NR. Please, that's very nice. All right, I would like to just go over what is going to be in your test again. So I would like you just to make a little note, just say test content. I want to make sure that there is no confusion about what geometry you must study, what. So we're just going to list all of it. Okay, guys, so you are doing geometry, right? You need to know your triangle geometry. So triangle. That's angle sum of triangle, exterior angle of triangle, and the reasons for isosceles triangles. So I'm going to list the reasons here. You need to know how to do calculations with these, and you need to know these reasons. Okay, so angle sum of triangle, exterior angle of triangle. Then you need to be able to do angles opposite equal sides. And also, guys, we haven't practiced it in a while, but there are definitely examples in your books. where they give you that two angles are equal, and then you must say that the opposite sides are equal, right? So that reason is similar to this. It's just angles and sides are swapped around. So sides, opposite, equal angles. Okay, those are the four triangle reasons that you need to be able to use and write down. Okay, so make sure that you look at examples of all of those reasons. Then also you need to be able to classify triangles, guys. So saying isosceles or equilateral, and then you also need to be able to say whether it's an acute angle, obtuse angle, or right angle. Okay, we did a whole table in your book, so you can find a thing of how you can classify triangles. Okay, then you need to be able to do geometry of straight lines. You can actually say straight and parallel lines. Now guys, we summarize all of these rules and all of these types of questions or angles that they can ask you when we did our fuzzy X summary. I'll show you now again what that is. But we wrote like F and then a U and then a Z and a Y and an X, and we wrote stuff underneath each letter. I'm just going to go back to that page and just note the thing. It will be, I think we did it at the beginning of the term. Let me just picture the geometry. Oh dear, I can't find it on my notes. Can you guys find it? Just check quickly. I'm not sure now where it is in my notes. What? Yes, yes, yes. Can't see, but I'm sure it's fine. Okay. Oh, wait. I was looking at the wrong note. Okay, I found it. Yes. It looks like this, guys. That's what I'm talking about. Fuzzy X. That's a full of baby. Yeah. Okay, guys, so you need to know how to work with corresponding angles, criteria, ultimate angle on a straight line, right? That's the Y. But you can also kind of do angles around the point for the Y, I suppose. Okay, and then vertically opposite angles. That's the other one. That's the X shape. Okay, so make sure you go over that. That's what I'm talking about when I say fuzzy X. All right, sorry, not that one. Let's go back to this one. Okay, are we all fine on that? Or was that? Yes. Then we did equations. No, we haven't even done that. Okay, equations. I don't really have to say anything more than that. You need to be able to solve equations. So I'm just going to say solving for a variable, yeah. 15. The math states are always out of 50, guys. All the way up to 50. Okay, so you need to solve for variables. So those different types, right? Where you must remember where you have variables on both sides, brackets on both sides, you minus them off, you minus them off, all of that stuff. But we did them in separate notes, so you can go look at all of that. The extra thing, guys, is these types of questions that we have today, where you have to set up an equation in a geometry question and then solve it. Okay, so you must be able to do that as well. So I'm going to just write here, set up an equation let me just do it in a little bit. So guys, this sounds very complicated, but this is what we mark today. Okay, so when you have three angles and a triangle, and you say this angle plus this angle plus this angle equals 180. That is setting up an equation. Okay, so where we had like b plus 2b plus 25 equals 180. That's setting up an equation. Then solving the equation is where you then actually calculate the value. Okay, so we have done this. We've done lots of questions on this now. And that's basically it for equations, guys. All the different types of equations that we did, from the very basic ones all the way through to the ones where you have brackets on both sides, and then where you are mixing equations and geometry together. The next section, and I thought I was going to get to it today, but we'll have to revise it a little bit tomorrow, is what we did last term, right? Which was factors. But guys, I'm not giving you homework today. Your homework is going to be, if you don't understand that word, you're going to have to go watch one of the videos, depending on which one you don't understand, on Google Classroom, right? They're on the zero rated server. But did I post the notes? I think I did, hey, on Classroom, yes. If you want to, you can just read through the notes. Maybe that is enough of an explanation, but we will go through it tomorrow, but very quickly. We can't spend too much time on it. But factors, guys, you need to understand what is a prime factor. Do we know what it is? What is a prime factor? You're almost there, yes, David? Yes, so even if we're just talking about a prime number is just a number that can only be divided by itself and by 1. All right, so we can write that down. I can't remember if we must have written it on the note as well, but let's just add it here. Number that can only be divided by 1 and itself. Now guys, did I tell you what the opposite of a prime number is? Composite number. Do you remember that term? Did we do that together? You might have done it in primary school. Let's add it to this list, please. A composite number or composite factor, it doesn't really matter. So I'll just write here a composite number is just the opposite of a prime number, right? So it can be divided by more numbers than 1 in itself. All right, so if I'm thinking about like 10, which numbers can you divide into 10? Which numbers go into 10? 10 and 1, right? So 1 in itself, but then also 2 and 5. Okay, so any number that has more factors than 1 and itself. Let's just write a couple of examples down. 10, what else? What other number would be a composite number? 20. What else? 15, 12. Someone said 8. What about 1,000? Hey? 10,000. Yeah, we can keep going. All right. 66. Yes. Okay, that's the last one I'll write down. Here we go. Guys, if they give you a list of numbers, right, you need to actually be able to identify from the list which ones of those are prime numbers and which ones are composite numbers. Yes. Yes, exactly. Yeah. Now, guys, what about the number 1? Yeah, 1 is not a prime number. It's also not a composite number. It's just 1. It doesn't even have a name. So it's just 1. Yeah. It's just one number. All right, it's just 1. Okay, so they might try and catch you out with that, guys. 1 is not a composite and also not prime. Okay, it's odd, yes, but I mean, if they're asking you to like classify them according to that. Okay, very quickly, we're running out of time. You need to be able to write a number as a product of its prime factors. We did the ladder method, right? The factor ladder. I'll just show you again tomorrow. And guys, you need to be able to do this without a calculator. Very important. So when you're practicing these at home, do them without a calculator. The other thing that you need to be able to do is to find the HCF, highest common factor, right? And LCM, lowest common multiple of multiple numbers. Again, without the use of a calculator. So what we did in class was we used the product of the prime factors, and there was a whole method that we used for that. Then, guys, something that I think we didn't get to last term, so we'll have to do that tomorrow, is to find the square root or cube root of a number. I'll show you how to do that. That's when you write them as a product of the prime factors, then you can use that. So I'm actually going to highlight this to remind myself that we need to do this tomorrow. And then the last thing, very quickly, we still have 2 minutes, was, I'll squeeze it in here, it's number 4, was scientific notation. All right, so you have to be able to go from decimal notation, which is just a number that's written as a number, so like 25 million, we call that decimal notation, to scientific, I'm just going to abbreviate it, sci notation, like that. You have to be able to do that. And then you have to be able to go the other way around. So you need to be able to go from a number in scientific notation to decimal notation. So guys, we did this in one lesson last term. So there's only one video that you need to watch for that. So if you weren't in class for that, or if you can't remember, please go watch that video. I will just do an example of each tomorrow. Okay.